All right, John Aaliyah. I'm gonna walk through some of my comments, see if this helps you. Instead of I've typed them up, but I think the verbal will probably help. So let me get it like this, and that way I can work through it. First of all, great list of independent and dependent. What I think you are my top student as far as what a table should look like, and all this work prior to it, as far as I'll just use my little pen to highlight things. Listing independent variable and dependent variables, I'm going to be able to do so much stuff with that. So thank you for doing that. Delete that. Uh, as far as table 2, you've got the letter types, which is fine of what you used, but you should definitely include the K values themselves, those newtons per meter. Oops, right there, delete that. Which are included way down here. I don't think D is in there, but every time I tried to do it on the video, there was an error. So hopefully you can get enough data with 4 points. Anyway, so include those in the table because you're going to have to redo your graph for that. On the displacement, you can see everything's about a 0.46, 0.46, 0.45, 0.45. It's a pretty small change. And then you got a 0.59. I'd consider that an outlier and maybe throw it out. Okay. And then we get into this. As far as graphing, always graph your 0, 0. And then if you thought the trend was linear, right, where if I were to extend it to 0, 0, right, I have to think about my intercept. Okay. What would my intercept be if I continued that trend line to 0, 0? So at 0 mass, what would my period be? And that should help you. But right now, if I continue that, it'd be if I put 0 mass on a spring, which shouldn't move at all, I'm going to get a 0.3 period. So 0.3 seconds, this is going to cycle. To me, that tells me I've done my intercept wrong. So I also have to think, if I have 0 mass, guess what? I've got 0 periods. So that's going to put me down here, which should also help you identify, put the green line there, identify that trend. Okay, I think I'm getting to you. You can see that, which means you're going to have to, you said it was linear, you're going to have to recreate or create a new linearized graph for that data. Uh, so, again, spring type versus period, replacing those numbers or those letters with actual values for the spring constant, because that's what's changing. While we're changing the type, for sure, we are changing specifically the spring constant. And you'll see A through E. They don't necessarily go in numerical value. A is small, B is huge, C is very small, a D we don't know, and E is small also, as far as newtons per meter. So plot those, and that will help get some data. And then kind of gave some input here as far as what is the impact of changing your displacement and the period. And that horizontal line should give you some impact. So taking the square root of that is that's where you don't need to do that. And then based on what you're going to find, right, by your new linearization, you're going to have to rework that conclusion. Okay. I would say the best looking lab so far, pretty complete. The way we graphed it, right, and possibly the use of outliers and using labels instead of data, like numerical values, are the things that kind of led you astray on determining your outcomes or finding good, solid conclusions, which is just a step away. So, yeah, I'm going to post these comments. They're written on the side, but hopefully this will help you rework your lab.